Alright, so now let's talk about ellipses. So what is an ellipse? Well, if you take two constants a and b bigger than 0, then you let c squared equals a squared minus b squared. Right? So then let's look at the one case first, and then we'll look at the second case. Well, first case is we look at the following curve, or the following equation. X squared over a squared equals plus y squared over b squared is equal to 1. Right, so what does this curve look like? Well, if you make x equal to 0, and you see that y is plus or minus b, and if you make y equals to 0, then x is plus or minus a. Right. So we can get a pretty nice idea of what this looks like. It's x is y, there's a, and there's minus a, there's b, and there's minus b. So our curve looks something like that. Right. Now you see this point here, and x is minus a and y is 0, and x is equal to a and y is equal to 0. These are the 2 points on the curve that are furthest apart. Right, so we call them the vertices. Right. Right, because they are the 2 points that are furthest apart. Right. You can see this ellipse has 2 axes of symmetry. In other words, if you look, it's completely symmetric around the x-axis and around the y-axis. So if you fold the parabola of the ellipse like this on the x-axis, the top and the bottom halves will fall exactly on each other, and if you fold it like that along the y-axis, the same thing is going to happen. Right? So the axis on which the vertices lie, right, we call that the major axis. Right? And the axis, the other axis of symmetry, of course, we're going to call the minor axis. Right. Now, what does this c have to do with anything? The c squared we have here. Well, if we mark off the 2 points, say there and there, so minus c0 and c on the x-axis, these 2 points have a very special property. If you take a point anywhere on the ellipse, say a point over there, and you calculate those 2 distances, d1 and d2, then if you add them up, right, you'll always get the same answer. Right. So we get d1 plus d2 equals a constant, k. So these are 2 very special points for the ellipse, and we call them the foci of the ellipse. Right. Right, so the foci are at plus or minus c0. Right. So the foci and the vertices of the ellipse, right? Those are actually the 2 defining features. If you know the foci and the vertices, right, then you know what the ellipse looks like. Right? Then you can find the equation for the ellipse. Right? So that's the first case. Right. Now the second case, all we're going to do is we're going to interchange the roles of x and y. So we're going to look at y squared over a squared plus x squared over b squared is 1. Right. So now you see what's going to happen is this picture is just going to sort of rotate through 90 degrees. Right? So now the x-intercepts will be at B and minus B, the y-intercepts at A and minus A. Yeah, so that is because A is bigger than B, right? This distance is now the largest distance between any 2 points on the ellipse. Now we call the y-axis the major axis. The x-axis is now the minor axis. Yeah. And these 2 points where y is plus or minus a and x is 0, these are now the vertices. Right. Right. And the foci, they're now going to sit here on the y-axis. Right. So 0 plus or minus c these are now the foci. Right. So you see, if you want to see where the vertices are, right? Right? If x is divided by the bigger number, right? So say if we have x squared over 9 and y squared over 4, right? If x is divided by the bigger number, then the vertices sit on the x-axis, right? If y is divided by the bigger number, then the vertices and the foci sit on the y-axis. Okay. Now again, all the ellipses we're going to look at will be of this form, right? Except maybe they'll be shifted horizontally and vertically. Okay.